Okay, so welcome to one of the last lectures in our series on ratios and proportions. Proportions can be very useful in maths, and we can use them to work out corresponding lengths in similar shapes like triangles which are similar to each other or polygons which are similar to each other. Before I begin, if you have found yourself watching this lecture and you're not already a subscriber to my math channel, you are welcome to press subscribe below here and join our daily lectures so that I can help you with your maths. And that way you can also go catch up on any missed lectures, or they are all on my channel. Welcome aboard. Right, so let's look at this quickly. So proportions can be used to find the length of corresponding sides of similar triangles and polygons which are similar. Okay, so look, how does this work? Well, let's have a look. So yeah, we've got two triangles. We've got triangle ABC over here, and we've got triangle DEF over there. And they are similar. In other words, they are totally in proportion to each other. So therefore, we can work out this unknown side here by setting up a proportion. So we can say, fine, 3 over there over 6 over here would make this ratio here. So 3 over 6. And then we're going to do that and that. So we can solve for x. So we can use side for side. So you see you're doing the same side. And then we're solving same side. Okay, so let's go set that up. It's very simple. You just have to make sure you use the correct corresponding sides when you set up your ratios for your proportion. So we have 3 over 6 is equal to x over 4. So this side over that is this. And that side over that is that, with our equal sign in the middle. Now we can solve for x quite easily because we've set up a proportion based on the similarity of these two triangles. So now we start solving. We do our cross multiplication like that, and we end up with 6x equals 12. Then we're going to divide by 6 on both sides to isolate our x, and we get x is equal to 2. So this value here is actually a 2. Okay, so that was nice and easily sorted. Let's do another type of shape. Now we have a polygon. We know this is a rectangle. And this large rectangle is similar to the small rectangle and vice versa, which means they're in proportion to each other. Our unknown is this side, so we're going to set up a proportion. And we're going to say, fine, the first one we're going to use is 4 over 2 is equal to x over 4. So 4 over 2, there it is there, is equal to x over 4, side for side. You see, you just keep them using the correct sides that are similar to each other. Now we're going to do our cross multiplication with our proportion, and we're going to come out at 2x is equal to 16. Then we're going to divide by 2 on both sides to isolate our x, and we get x is equal to 8. So this side here is actually equal to 8, and because it's a rectangle, that one will also be 8. Easy to solve these things when you set up your proportions properly. Let's look at one final shape. We have another shape here with an unknown side, and we have a large one and a small one, and they're similar, which means we can set up proportions which are ratios in proportion to each other. And let's do the first one will be side for side. It would be x, 6 over x. So we're going to go that side over that side is equal to that side over that side on the smaller one. Okay, so now let's have a look. We're going to cross multiply. We're going to get 3x is equal to 12. Now we're going to isolate our x by dividing by 3 on both sides, and we're going to get x is equal to 4. So this is also 4 over here. That was what our x value came to. Okay, so you get an idea. It's always, you keep your sides exactly the same that you work with on each side of the proportion. Yeah, we had a 6 and an x, so there we were a 3 and a 2. There we go, like that. Okay, so I hope you understand that and how you can use these to your benefit in maths. See you in tomorrow's lecture.